Okay, a very good afternoon, students. Welcome to the class. So before starting the class, let me know I'm clearly audible to you all and the screen is clearly visible to you all. So please text me in the chat box if you have any issues. Okay. So please text in the chat box so that I can not clearly audible to you all and the screen is clearly visible to you all. Fine. Okay. Okay. If everything is clear, then let's go ahead with our class. So students, in our previous class, we have learned about the geometric mean, harmonic progression, harmonic mean, and we solve few problems based on that, right? I also given a homework to you all. So have you all solved the homework? Yeah? Yes. Well, we'll discuss about the homework question too. So this is the content that we're going to discuss in our today's class, right? So today what we'll do? Today we'll discuss about the relation between the arithmetic mean, geometric mean, and harmonic mean. After that, we'll discuss arithmetic geometric progression, what actually it meant by, how to compute it and all. Then we'll discuss sigma notation, what's sigma notation, its properties, and we'll also discuss some special series whose sum is already known to us, and we apply those special series to find sum of some other series. Okay. So this is the content that we're gonna discuss in our today's class. Fine. So let's begin with our class. Next. Okay. Well then, so let me see how much you remember about the previous class. So what are the things that you remember from the previous class? So this is here we have a few questions. So please do answer them in the chat box. So the first question is, if A1, A2, A3 up to AN is a GP of positive terms, then log A1, log A2, log A3 up to log AN is. So what this question is like, here in this question they're asking if A1, A2, this all things are terms of GP, then log A1, log A2, log A3, this all will be terms of what? Which progression? This is what they are asking us. Okay. So let me know answer in the chat box. Come on. Text in chat box. Well, this log A1, log A2, log A3 up to log AN, this all are terms of what? Arithmetic progression. This we discussed in the previous class in the properties of geometric progression, right? While discussing the properties of geometric progression, we discussed about this point too, isn't it? So what is the next question? Next question is, if G1, G2, okay, sorry, this is G2, G1, G2, G3, so on up to Gn are n geometric means between A and B, then product G1 into G2 into G3 up to Gn will be equal to, yes, even this point we discussed in the previous class while discussing the geometric mean, right? So tell me, what is the product of n geometric mean is equal to? Answer me in the chat box. Come on. Okay. So product of n geometric mean will be equal to a single geometric mean between A and B power n. So single geometric mean between A and B will be what? Root of AB, and raise this value to the power n. Then we will get product of n geometric mean. So is this clear to you all? Any doubt in this? Anything need to be explained? Yes? So the YouTube students can reply in the chat box, in the live chat, and the Zoom students please reply in the Zoom chat box. Okay? Well, Okay, if this is clear to you, then we'll move on to the next. Fine. Well, this was the homework question. So in the previous class, I had given few homework questions, right? So let's discuss one of them. So in the homework question, what actually they asked is if A1, A2 up to AN are in HP, then the expression A1 into A2 plus A2 into A3 plus so on up to AN minus 1 into AN is equal to, yes, this all n terms, these n terms are in HP. Then what will be the value of this expression? That's what they're asking us. And we have 4 options too. Correct? Well, this question was asked in the AIEEE 2006. Fine. So let's see how to compute it. They have mentioned here that A1, A2, A3, so on up to AN are in HP. Fine. If this term are in HP, what can I say about the reciprocal of these terms? Tell me. Answer me in the chat box. If these terms are in HP, what can I say about the reciprocal of these terms? Yes. That is 1 by A1, 1 by A2, 1 by A3, so on up to 1 by A8. Yes. So reciprocal of these terms will be what? They'll be in AP, arithmetic progression, okay? Right. So in arithmetic progression, we know that difference between any two consecutive terms is what? Same. So let me consider common difference here equal to D. Fine. So from definition of arithmetic progression, I can write 1 by A2 minus 1 by A1 is equal to what? D. Correct? So this will imply A1 minus A2 divided by A1 into A2 is equal to what? D. Fine. So now take A1, A2 term one side and this remaining terms on other side. What we will get? We'll get A1 into A2 equal to, yeah, correct. A1 into A2 into D. I'm just shifting these terms, okay? A1 into A2 into D is equal to what? A1 minus A2. Correct? Similarly, 1 by A3 minus 1 by A2 will be what? T3 minus T2. Even that is, it will have a common difference, right? So that will be equal to D. Correct? So what does it imply? It will imply A2 minus A3 divided by A2 A3 is equal to what? Is equal to D. This will imply A2 A3 into D is equal to A2 minus A3. Fine. Okay. Similarly, if I continue for remaining all terms, 1 by AN minus 1 by AN minus 1 will be equal to what? It will be equal to D. So this will imply AN minus 1 into AN into D will be equal to what? AN minus 1 minus AN. Okay? Just observe this. Now here you can observe in the LHS we have A1 into A2. In the second equation we have A2 into A3 and so on. If I continue writing this, here in the nth expression we'll have AN minus 1 into AN, right? So what we will do, we will just add this all equations. Okay? We'll just add this all equations. So on up to this all. So when I add them, what we will get? We will get A1, A2 into D, A1 into A2 plus A2 into A3 plus so on up to AN minus 1 into AN into D equal to A1 minus A2 plus A2 minus A3 plus so on up to AN minus 1 minus AN, right? Just observe here, A2 get cancelled. Similarly, this minus A3 will get cancelled with the next term A3. So remain the in between terms, in between A1 and AN, if I continue like this, all the terms get cancelled. So only the terms that remain with us will be A1 minus AN. Okay. So here we have A1 into A2 plus A2 into A3 plus so on up to AN minus 1 into AN into D. Okay. That's all we have. Fine. So let me write it's the equation A. Fine. Now I want the value of A1 into A2 plus A2 into A3 so on up to AN minus 1 into AN, right? So I want this value. For this, I should know value of D also, right? If I want to know this, I want to know the value of D also. So what I'll do, I'll try to find value of D now. Well then, what can we do? We know one information. What is that? We know that this expression 1 by A1, 1 by this terms 1 by A1, 1 by A2, 1 by A3, so on up to 1 by AN are in AP. So it means what will be the nth term? Tell me. Nth term will be 1 by AN is equal to nth term of AP. Wait, I'll write it as nth term of AP. Fine. Okay, nth term of AP will be what? It will be 1 by AN minus 1 is equal to 1 by A1 plus N minus 1 into D. Fine. So now what does it imply? It will imply N minus 1 into D is equal to 1 by AN minus 1 by A1, right? So just cross multiply, we will get D is equal to A1 minus AN divided by A1 into AN. Just shift this N minus 1 other side. So it will come in the denominator. So this will be the value of D that we're going to get. Correct? Well then, just replace this D value in our equation 1. So let me write that here. Okay. So from A, we can write A1 into A2 plus A2 into A3, so on up to AN minus 1 into AN is equal to what? Into D is there, right? So we'll replace the D value also. Yes. So into D, the D is nothing but A1 minus AN divided by A1 into AN into N minus 1 equal to A1 minus AN. Correct? So just observe here, these two terms are same. So they get cancelled. So what we will remain with? We will remain with A1 into A2 plus A2 into A3, so on up to AN minus 1 into AN is equal to A1 into AN into N minus 1. So this will be the value of the expression. So the expression given in the question was A1 into A2 plus A2 into A3, so on up to AN minus 1 into AN, right? So its value will be equal to what? It will be equal to A1 into AN into N minus 1. So which will be your right option? A1 into AN into N minus 1. So option B. Option B will be what our right option. Correct? So how many of you solved this homework question at home? So if you have solved it, so then please cross verify this. If you haven't solved, then please go through this once. Okay? Just go through it. And if you have any doubt, please do ask in the chat box. Okay. This is the next position. Okay. Well then, I can see that people don't have any doubt. So if no doubt, then we'll proceed further. Right? Next. Well, next is relation between AM, GM, and HM. That is arithmetic mean, geometric mean, and harmonic mean. So if what is the relation that we have? Let's see. If AGH are respectively arithmetic mean, geometric mean, and harmonic mean between A and B, both being positive, then G square is equal to A into H. Okay? And also arithmetic. So whatever the condition is, if A, G, H are arithmetic mean between A and B, then arithmetic mean will be always greater than or equal to geometric mean, which is greater than or equal to harmonic mean. Okay, so please do remember these relations. Okay, we're gonna make use of this relation in while solving the problem. Fine. Yes. Let me box them. Fine. Okay. So please do remember these relations. Now, what if we have n positive real numbers between A and B? Say let A win A2, so on up to AN, be n positive real numbers. Then we define then arithmetic mean is equal to what? A1 plus A2 plus A3, so on up to A divided by n. So this we discussed. And geometric mean by A1 into A2 into A3, so on up to AN whole raised to 1 by n. Okay. And harmonic mean is defined by n divided by 1 by A1 plus 1 by A2, so on up to 1 by AN. Fine. So if we have n positive real numbers, this is how we define arithmetic mean, geometric mean, and harmonic mean. Okay, of those terms. Now, next is a note point. Arithmetic mean is always greater than geometric mean, greater than harmonic mean. This is the inequality we had, right? It will hold at either places if and only if A1 is equal to A2 is equal to A3, so on up to AN. What do we mean by this? By this, we mean that if all these terms are equal, then arithmetic mean will be equal to geometric mean, and it will be equal to what? Harmonic mean. How is it possible? Okay, just assume this all these n terms are equal. Say it is equal to A1, then what will be the arithmetic mean? It will be equal to A1 plus A1, so on up to n times, right? A1 divided by n. This is n. Okay. Well, so it will be equal to what? It will be equal to n into A1 divided by n. That is equal to A1. Now, what will be the geometric mean? Geometric mean will be what? A1 into so on up to n times A1 whole raised to 1 by n. We are multiplying this A1 n times. So it's gonna be what? A1 raised to n whole raised to 1 by n, right? That is nothing but again an A1. And what will be the harmonic mean? Harmonic mean will be equal to n divided by, wait, okay, n divided by, tell me, 1 by A1 plus 1 by A1 plus 1 by A1, so on up to 1 by A1, n times. We are adding this reciprocal of A1 n times. So what we will get? We will get n divided, whole divided by n divided by A1. Why? Because denominator is same, so we can add the numerator directly. There are n terms, so we will get n divided by A1, right? So it will be equal to what? It will be again equal to A1. So if all these n terms are equal, then arithmetic mean, geometric mean, and harmonic mean will also be equal. This is what the note point says. So is it clear to you all? Any doubt in this note point? Yeah? Any doubt? Okay. If there is no doubt in this note point, then we'll move further. Next. So next here we have a problem, okay? So let's try to solve this. So what does this problem state? States that the arithmetic mean of two numbers exceeds the geometric mean by 10, and the geometric mean exceeds the harmonic mean by 16. Find the numbers. Fine. So let A, G, H be arithmetic mean, geometric mean, and harmonic mean of two numbers respectively. Okay. Of two numbers respectively. Now, according to the given data, what actually they are given? They are given that arithmetic mean of two numbers exceeds the geometric mean by 10. So A is equal to what? A is equal to G plus 10, right? And geometric mean exceeds the harmonic by 16. So G will be equal to what? H plus 16. Correct? Fine then. And sorry. Here, it's not a geometric mean, okay? It's actually arithmetic mean itself, which exceeds the harmonic by 16, right? So it's gonna be A is equal to H plus 16, fine? Just small error in the question. That is not GM, that is AM itself. So A is equal to H plus 16. Now, see, both are values of A, right? Just equate them. What we will get? We will get G plus 10 is equal to H plus 16. So G will be equal to what? G will be equal to H plus 6, right? Correct. So is it correct or wrong? Tell me. Okay. So what will be H equal to here? H will be equal to G minus 6. H equal to G minus 6. Fine. Now from our previous data we have something, right? We have a relation between G, A and H. What is that relation? Tell me. Answer me in the chat box. What is the relation between G, A and H? Yes, Jamie Chitradurga, Jamie Baldari. Answer me in the chat box. If A, G, H are the arithmetic mean, geometric mean and harmonic mean, what will be the relation between those three? G square is equal to what? We have this relation, right? We have G square is equal to A into H. Correct? Fine. Now, we know value of A in the terms of G, that is G plus 10. And we also know value of H in the terms of G, that is G minus 6. Correct? So what we will do? We'll just make use of this both data, okay? A and H. We replace that in this equation, equation 1. Fine? So what we will get? We will get G square is equal to A plus G plus 10. Correct? And what do we get in H? In the H place, we will get G minus 6. Correct? Now just simplify this. It's of the form A plus B into A minus C, right? Just simplify and bring back to the quadratic form. What do we get? Yes. We will get G square. Just multiply minus 6G plus 6G, plus 10G minus 66, right? So G square will be, G square get cancelled. So we will get, just shift this G terms on other side. 10G minus 6G is nothing but what? 4G, right? So 4G will be equal to what? 60. Oh, sorry, this is 60. 60, right? So G will be equal to 15. Correct? G is equal to 15. Fine. Now we got the value of G. We need to find the numbers, right? Let those numbers be what? A and B. Let those two numbers be A and B. So geometric mean between A and B is what? 15. It means root of A into B is equal to what? 15. Correct? Now, next step is write down the A. Write down the square on both the sides. We will get A into B is equal to 15 square, that is, 225. Now write A in the terms of B. What we will get? Write A in the terms of B. So we'll get A is equal to 225 divided by B. Correct? So we get A is equal to 225 divided by B. Fine then. Now we have this relation, right? A is equal to G plus H. Consider it. A is equal to, we have G plus H or G plus 10. So A will be equal to, we know what is G is. G is what? 15. 15 plus 10. So it's gonna be what? It's gonna be 25. So what is arithmetic mean between A and B? Tell me. How do we find arithmetic mean between A and B? It's a formula to find it. If A is a single arithmetic mean between A and B, what it is equal to? Answer me in the chat box. Yes. What this A value is? It will be equal to, yes, A plus B divided by 2 equal to 25, right? Well, so A plus B will be equal to what? A plus B will be equal to 225. Now just replace B, our A value here. A value back. So we will get 225 divided by B plus B equal to 225. Sorry, this is 50, right? 25 into 2. What am I writing? Sorry. So this is 50. So it will be 50. So now when you take a LCM, what you gonna get? You will get 225 plus B square plus 50 is equal to 50B, right? Okay, take all the terms on one side. You will get B square minus 50B minus plus 225 equal to 0. This is nothing but a quadratic equation, right? So now tell me the roots of this quadratic equation. Answer me in the chat box. What are the roots of this quadratic equation? Let me know. What are the roots of quadratic equation? Answer me in the chat box. YouTube students as well as Zoom students, answer me in the chat box. What are the roots of this quadratic equation? Well then, when you solve this quadratic equation, what will be the roots? Roots will be B is equal to 45 or B is equal to 5. Okay. So these are the roots of quadratic equation. When if B is equal to 45, what will be the other number? A. Just make use of this relation. A plus B is equal to 50. So other number will be equal to what? 5, right? And if B is equal to 5, then A will be equal to 45. So we get two sets of number. When if A is 5, we get B as 45. These are the two numbers. And if B is 5, we get A as 45. Okay, two sets of numbers. So is it clear to you all? Any doubt in this? Any doubt in this problem? How to compute it? Yeah? Just whatever data is given to us, write it down. Fine. First step, what you have to do? First read out the question and whatever data is given to us, write it down. This is the data given to us. Write it down. Next, just try to analyze how you can compute it. How you can find the required values. Okay. So is it clear to you all? Any doubt in this? Well, okay. If no doubt in this, we'll move ahead. We'll go to the next part. Next. Well, next we have one question from the JEE, okay? It's a JEE 2021 Shift 2 question. So let's see what the question says here. Question is, if arithmetic mean and the geometric mean of pth and qth term of the sequence, this is the sequence, minus 16, 8, minus 4, 2, so on, satisfies the equation 4x squared minus 9x plus 5 equal to 0, then p plus q is equal to. Fine. what they're saying? They're saying that arithmetic mean and geometric mean of pth and qth term of a given sequence, that is minus 16, 8, minus 4, 2, so on, it satisfies the equation 4x square minus 9x plus 5. Fine. Then p plus q is equal to. What do we mean by it satisfies the equation? By that we mean, if we find the roots of this equation, that root should be equal to arithmetic mean and the geometric mean of this p and q. Okay? Well then. So let's begin this. Let's see. Before that, tell me, this is the sequence that we have. Minus 60, 8, minus 4, 2. Tell me what kind of sequence is it? Answer me. Just look at the pattern and answer me what kind of sequence is it. Is it AP, GP, HP? Yes. Observe it and tell me what kind of sequence is it. Answer me in the chat box. Okay. So you can observe the sequence. This sequence is nothing but it's in GP. Why? Consider this consecutive ratio terms of this consider the ratio of this consecutive terms. Okay. What is 8 by minus 60? 8 by minus 60 is what? Minus 1 by 2. What is minus 4 by 8? It's again minus 1 by 2. 2 by minus 4. It's again 1 by 2. Minus 1 by 2. So here we are getting what? Common ratios. So consider any two consecutive terms, and if you take a ratio, you are getting same value. That's the reason we can say the sequence is in GP. Okay. Now, so what will be the pth term of this GP? TP will be equal to first term, that is minus 16 into R, that is minus 1 by 2 whole raised to P minus 1. And what will be TQ equal to? TQ will be equal to minus 16 into minus 1 by 2 whole raised to Q minus 1. Okay. Let me know this. Okay. Fine. This is a GP with R is equal to minus 1 by 2 and A is equal to minus 16. Fine. Now, let me try to find the roots of this equation. Why? Why? Because roots of this equation are nothing but AM and GM. Fine. So, x square, 4x square minus 9x plus 5 equal to 0. If I split this, what I am going to get? I will get 4x square. Any doubt, Chain me Ballari? Okay. Yeah, fine. That's right, Chain me Ballari. Very good. So it's a geometric progression, fine. 9. So 4x squared minus 5x minus 4x plus 5 equal to 0. Fine. 5 4s are 20 that we're gonna get. So now take these two terms, consider these two terms, 4x square minus 4x. If you take 4x common, you will get what? You will get x minus 1. And then take minus 5 common, you will get x. Sorry, this is x plus 1. Oh, here we have a minus term. That's it. Yeah, it's correct. Correct. Take minus 5 common here, you will get x minus 1. Okay. Now what we will get? We will get 4x minus 5 into x minus 1 equal to 0, right? Correct. So what are the two roots we're gonna get here? The two roots that we're gonna get will be x is equal to 5 by 4 and x is equal to 1. Now tell me, we got two roots and they're saying roots of this equation are arithmetic mean and geometric mean. But how to decide which is arithmetic mean and which is geometric mean? Yes. Tell me among these two values, which is geometric mean and which will be the arithmetic mean? Which one I can consider it as an arithmetic mean and which one I can consider it as a geometric mean? Answer me in the chat box. Yes. Answer me in the chat box. In the first slide, we studied about the relationship between arithmetic mean, geometric mean, and harmonic mean, right? There we got one inequality. What was that? That was key. Arithmetic mean is always greater than or equal to geometric mean, right? So among this, which is the greater value? 5 by 4 or 1? 5 by 4 is greater than 1, right? So what can we say? We can say that arithmetic mean is equal to 5 by 4 and geometric mean is equal to what? 1. Fine? Okay. Next. So we got geometric mean value. This geometric mean is nothing but it's a geometric mean between pth and qth term. Fine? So geometric mean is equal to 1 and it's a geometric mean between pth and qth term. So I can write root of pth term, that is TP I'll write, that's better. TP into TQ is equal to 1. So square on both the sides, you will get TP into TQ is equal to 1 side. Now substitute the value of TP and TQ here. What is TP? TP is minus 16 into minus 1 by 2 whole raised to P minus 1, right? So next, minus 16 into minus 1 by 2 whole raised to P minus 1. Similarly, TQ is minus 16 into minus 1 by 2 whole raised to Q minus 1, that is equal to 1. Okay. So now we will get what? Just multiply and take this, we can write it as 16, we can write it as 2 raised to 4. This is the 2 raised to 4, so it's going to be 2 raised to 8, correct? 16 into 16, right? That can be written as minus 2 raised to 8. Wait, let me write it properly. Okay. Yeah. So minus 16 into minus 16 we have. This I can write as minus 2 raised to 4. I'll combine these two terms, okay? And this is also minus 2 raised to 4. It's gonna be 1 divided by minus 2 raised to, P plus Q minus 2, right? Equal to 1. Fine. Take this term on other side. So this is nothing but A raised to m into A raised to n. That is A raised to m plus n. So it's gonna be minus 2 raised to 8. This will be equal to minus 2 raised to P plus Q minus 2. Correct? I'm just shifting this term on other side. Now observe here. Bases are same here. So what can I say about the powers? When the bases are same, what can I say about the powers? Tell me. If bases are same, what can I say about the powers? I can equate the powers, right? Just equate those powers. So what it will imply what? It will imply 8 is equal to P plus Q minus 2. Fine? Sorry. So P plus Q will be what? P plus Q will be equal to 8 plus 2, that is 10. Right? So is it clear to you all? Any doubt in this question? Jamie Ballari, is it clear to you all? Any doubt in this question? Let me know in the chat box if you have any queries. Okay. Fine. Okay. Okay, if no doubts, then we'll move on. Okay, we'll go to the next one. So this is clear to you, all right? This problem. Fine. Okay. So let's go to the next part. So next we have one more question here. So this is a homework question. Please do try this question at home. If you are unable to find it, we'll solve this in the next class. But please do try it. Fine. If A1, A2 be two arithmetic means and G1, G2 be two geometric means between A and B, then A1 plus A2 divided by G1 into G2 is equal to. Well, we know, right? We know how to find nth arithmetic mean. The n arithmetic mean inserted between A and B. We know how to find rth arithmetic mean, correct? We have a formula for that. And we also know how to find the rth geometric mean when so many geometric means are inserted between A and B, isn't it? So just make use of that information and just try to solve this, okay? So let me see. I just need answer in the next class. Fine? Well, okay, the next part. So let's go to the next part now. Next is arithmetico-geometric series. Okay? Well, already answer been given by J.N.V. Chitradurga. Okay, very good. Very good, J.N.V. Chitradurga. So we'll discuss this question in tomorrow's class, but I want other students also to try it once. The answer being given, I don't want to share the answer, but please other students also try it, okay? I'll share the solution in tomorrow's class, fine? Okay. Well, so the next concept is arithmetico-geometric series. So what is this arithmetico-geometric series? A series, each term of which is formed by multiplying the corresponding terms of AP and GP is called arithmetico-geometric series. So let me explain this with an example. Okay. So let me consider one AP. Say 1, 5, 9, so on. Okay. This is AP. It's AP, right? Where first term is 1 and common difference is 4. And I'll consider one GP, 1 x squared, so on, right? It's a GP where first term is 1 and common difference is what? A common ratio is x. Okay. Now, how do we define arithmetico-geometric series? What we'll do is we'll just multiply the corresponding terms of AP and GP. So what's first term of AB? 1. First term of GP is 1. When you multiply it, you get 1. Plus second term of AP is 5. And consider the second term of GP, that is x. Multiply them. You will get 5x. Plus third term of GP, AP, and third term of GP. Multiply them. You will get 9x squared. So a series formed by multiplying the corresponding terms of AP and GP is known as what? Arithmetico-geometric series. Okay. In this series, you can observe coefficient of x are what? Coefficient of x are all in AP. And this x terms, this all are in GP. Fine. So is it clear to you all? Any doubt in this? Any doubt in this question? Sorry, this concept? Okay. Okay. If no doubt, we'll go to the next part. Just how, let's see in the next part, how we're gonna write them. This is an example, right? If you have a general AB and general terms of geometric progression, how we're gonna write it? So if A and D are what? First term and common ratios. First term and common ratios of AB and R, common difference of AB and R is a common ratio of GP. Then how we will write Sn? Sn is equal to A plus, second term will be A plus D into R plus third term A plus 2D into R squared, so on up to nth term Tn A plus n minus 1 D into R is to n minus 1. Okay, this is how we're gonna write arithmetico-geometric series. How to compute this? There will be so many terms in the series, right? Correct? If 20 terms they have given, there will be 20 terms in the series. How to find the value of that? Well, to find the value of the complete series, we make use of this formula. Okay, it's a general formula. So what is general formula states? It states that, okay, we have a time. So it states that Sn is equal to A divided by 1 minus R plus D into R into 1 minus R is to n minus 1 divided by 1 minus R whole square minus nth term of AP into R is to n divided by 1 minus R. Here R should not be equal to 1. Well. Isn't it too long to remember? Ma'am, we can't remember the differentiation formulas itself. How can we remember this? Are you all thinking this? Well then, if you're thinking, then pause for a while. We have a method to solve such arithmetico-geometric series, okay? You don't need to remember this formula. Just follow the steps and we will find the value of sum of the series. Fine? So this is quite hectic to remember, right? So what are the steps? Let's discuss them here. Okay. So steps to find the sum of the series. First step is we must write down the Sn, the arithmetico-geometric series. Okay. Right. First step is to write Sn. Fine. After that, second step, after writing Sn, multiply Sn, this sum of the series, this thing, by what? R, that is common ratio, okay? Multiply it by common ratio. And third step is what? Just subtract Sn into R from Sn. That is, you have to find Sn minus Sn into R. Okay, this is what. After you compute this all, you will get one geometric series. Okay, you know how to find the sum of the geometric series, right? Sum, except first term and last term, middle terms, whatever you have, those terms will be in the geometric series. So using the geometric series formula, compute it. Right? Then next step, compute the GP terms. Okay. So this is how we find it. I know it's quite confusing if I just explain you the steps. So let's go ahead with one example. Okay. Let me explain this with one small example. I'll take this one only, the previous one. Here I took an example, right? The example was 1 plus 5 plus 9x squared, so on. So this is nothing but it's a geometric series, correct? So I'll take this one only. Next. So 1 plus 5x plus 9x squared plus so on. This is nothing but it's a 13x raised to cube. Okay, let me write one more down. This is nothing but it's a geometric, arithmetico-geometric series, right? Okay. Now let me consider this as a Sn. What's the first step? To write a Sn. We have written the Sn. In the second step, what we will do? Multiply it by a R, that is common ratio. What is common ratio here? So common ratio here is what? X, right? So multiply it with X. What we will get? We will get X into Sn. So we will get X plus 5x squared plus 9x cube plus 13x raised to 4, so on. Correct? Fine. Now, third step. What's the third step? We need to find difference of this both, that is Sn minus xSn. So just subtract this both the series. What you will get? 1 minus, nothing is there, 0. 1, I give it as it is. 5x minus x. Just 5x minus x. What it gonna be? It gonna be plus 4x. Now here I have 9x squared minus 5x squared. So it's gonna be plus 4x squared. So 13x squared minus 9x squared. That is 4x cubed plus so on. Okay. Now, this is equal to, just observe here. Well, I have considered the infinite series here. 1 plus, I can take 4 common here, right? When I take 4 common, what will I get? I will get x plus, I'll take 4x itself common. That's better. 4x itself common. Where is it? Yeah. So what I remain with in the bracket, inside the bracket, I will remain with, yes, that's correct. 4x 1 plus x square, x cube plus 1. Okay. Now tell me, 1 plus x square plus x cube is infinite series, and let's assume x is less, mod x is less than 1 here. So what will be sum of the series in this case? If it's greater than 1, of course it will be infinite, right? So I'm assuming mod x is less than 1. So what will be the sum of this geometric series? Tell me. 1 plus x square plus x cube, so on. Yeah, it's an infinite series with mod x less than 1. Its sum is equal to what? Text me in the chat box. It is equal to, yes, S infinity is equal to what? In the case of GP, it is equal to A divided by 1 minus R, right? Correct? So A is what here? A is 1 in this case, and R is x. So 1 divided by 1 minus x. So it's gonna be what? It's gonna be 1 plus 4x divided by 1 minus x. Correct? So this will be what? This will be the, wait. Here what we have? Here I take Sn common. I will get 1 minus x. So yes, Sn into 1 minus x. Now, I shift this 1 minus x on other side. It's gonna be 1 minus x whole square, right? Here 1 minus x. So yeah, so this will be nothing but it will be the sum of the given arithmetico-geometric series, right? We had such a big summation value here, that is series here, 1 plus 5 plus 9, so on. And see, we computed it and we found the value of it, correct? It's equal to 1 by 1 minus x plus 4x divided by 1 minus x into power x squared. So is it clear to you all? Any doubt in this? Jamie Chitralka, is it clear to you all? Any doubt in this? Any doubt in? Okay, very good. So you have understood, right? So let's revise it once. So what is arithmetico-geometric series? It's a combination of arithmetic progression and the geometric progression. When you multiply corresponding terms of arithmetic progression and geometric progression and you add them, you will get an arithmetico-geometric series. By computing its sum of the values is quite, there is a formula, but it's quite hectic one. So what we will do, we will make use of these steps, okay? First, we will write an Sn. After that, we'll multiply this Sn by R. And what we will do, we'll subtract that Sn minus Sn into R. After that, what we will get? We will get a series which involves a geometric series, okay? And we know how to compute geometric series. Using the geometric series formula, we'll compute it. Okay, so this is the procedure. Well, here this formula is for what? If n terms are given, it's not the sum of infinite series, it is for sum of first n terms. Okay, so when sum of infinite series is given, this will be the formula. But no need to remember this formula. Just go for this procedure. Go for this procedure for both first n terms, sum of the first n terms, as well as sum of the infinite series. Okay, to find both the cases. Well then, and in case sometimes you will solve this step. Okay, you will solve till Sn minus Xn to Sn. Okay, until this step is solved, but you don't get such common terms here. Again, you will get what? Arithmetico-geometric series only. After doing this step also, you will get arithmetico-geometric series itself. In that case, what you have to do? You have to repeat the procedure. Just you have to consider this as multiply it with the R, then subtract. Just continue. Repeat the procedure again until you get to one series which involves a geometric series. Okay. Well, here one example. We have an example. Just take it as a homework. Okay. Note it down. Note this expression and take it as a homework and let me know its answer in the next class. Fine. So this is about the arithmetico-geometric series. Do you have any doubt in this? Anything that to be re-explained? So please let me know in the chat box if anything has to be re-explained. YouTube students, as well as okay, as well as Zoom students. Any doubt? Okay. Fine. So please write down this question again. Write down this question and take it as a homework. So totally I have given 2 questions to you all. Please do solve them and bring the answer in the next class. So in the next class, what are things we'll do? In the next class, we'll discuss some more problems on this arithmetico-geometric series. One different kind of problem. After that, we'll see what is summation is. And after that, we'll see properties of the summation. We actually thought of completing this today, but due to time constraint, we couldn't. So no issues. We'll discuss that in tomorrow's class. And after that, we'll see how to compute a series. Right? We'll discuss some special series and how to compute the series using that special series. Okay. So these are the topics for tomorrow's class. Well, if you people don't have any doubt, then we'll wind up our class here and we'll meet in the tomorrow's class. Okay. Okay then. So okay, students. Bye bye. Have a nice day. So we'll meet in the tomorrow's class. Bye. Okay, Jane. Thank you.